Hello everyone, welcome back to my YouTube channel. We are going to start a new revision series for class 12 students for the subject of mathematics. So in this series, we are going to revise the important concept from each topic and we are going to solve PYQs of each topic. Today we are going to cover the theory part of the topic from Maths-2, that is differentiation. So what you are going to cover in this topic? First thing is that we are going to revise the basic formulas for differentiation. Next, we are going to see about how to differentiate a composite function, a inverse function, parametric function, logarithmic differentiation, differentiation of implicit functions, and lastly, higher order derivatives. Firstly, what is differentiation? So differentiation is a process of finding derivative of a function. Process of finding rate of change of function with respect to its variables. And it is denoted as dy by dx. So here we are going to find the rate of change of function. So here function is y is equal to f of x. So where f of x is a function with respect to its variable is x. So you're going to find derivative of y, that is derivative function f of x with respect to its variable x. It is also denoted as y dash. It means it is a first order derivative. Next, let us go to the basic rules of differentiation. So derivative of a constant is nothing but 0. Derivative of x raised to n, that is variable raised to constant. So if in this case, the derivative becomes constant into variable raised to constant minus 1. Then we have derivative of constant into some function. So that constant will come outside and it will be c into derivative of that function. Then we have the sum difference rule, product rule, and quotient rule. In sum difference rule, if you have derivative of one function plus another function, then both the function get separated. So derivative of first function is solved separately plus derivative of another next function is solved separately. Same for the sum and same for the difference. Next, we have product rule. So if you have two functions multiplied to each other, so derivative of f of x into g of x. So there we apply the product rule. Product rule states that if it is derivative of first function into second function, so we have to keep the first function as it is, f of x, and take the derivative of second function, that is derivative of g of x, plus now we have to keep the second function same, g of x, and take the derivative of the first function. So this is right. Product rule means it is nothing but u into v, u into derivative of v plus v into derivative of u. Similarly, if it is quotient, that is derivative of f of x upon g of x. So here the formula becomes g of x, that is v into derivative of f of x, that is derivative of u, minus u, that is f of x, into derivative of v, that is g of x. Denominator comes to be v square, that is g of x the whole square. Okay, so I hope you understood the basic rules of differentiation. Now let us come to the standard formulas of differentiation. Standard formulas are derivative of constant is 0. Derivative of variable raised to constant is n into x raised to n minus 1. Then if it is root x, our derivative becomes 1 upon 2 root x. If it is 1 upon x raised to n, our derivative becomes minus n upon x raised to n minus 1. For example, if it is 1 upon x square, it will become minus 2 upon x. And derivative of e raised to x is same, e raised to x. Derivative of log x is 1 upon x. Derivative of log x to the base a, then it is 1 upon log x, 1 upon x into log a. So here the base is e and log e is 1. That's why we are mentioning 1 upon x. Here the base is a, so derivative will be 1 upon x log a. Derivative of a raised to x, that is constant raised to variable. So here it comes a raised to x into log of constant. So these are the derivatives of standard function. Now let us see the derivatives of trigonometric function and inverse trigonometric function. So if it is a sin x, we have the derivative of sin x as cos x. Cos x minus sin x, derivative of tan x is sec square x. Derivative of sec x is sec x into tan x. Derivative of cosec x is minus cosec x into cot x. Derivative of cot x is minus cosec square x. So what is the trick to remember the signs? Whenever there is c, it will be a negative sign. So you can see cos you can see C here, it is a negative derivative. Its derivative will be negative. Again, for cosec x and cot x, the derivative will be negative. Derivative of inverse trigonometric functions. So sine inverse and cos inverse have the same derivative. Only the thing difference is sine x is positive 1 upon under root x square minus 1. In cos inverse, we have negative 1 upon under root x square. In tan inverse, we have derivative of 1 upon 1 plus x square. Same for cot inverse. Here we have minus 1 upon 1 plus x square. And for sec inverse x, derivative of sec inverse x is 1 upon x into under root x square minus 1. Same for cosec inverse x, it is negative of 1 upon x into under root x square minus 1. Same way here, wherever you came across C, the derivative will be negative derivative. So here are some formulas which will help you in solving inverse trigonometric functions. First one is tan inverse of A plus tan inverse of B. So whenever you came across this function, tan inverse of A plus tan inverse of B, you can write it as tan inverse of A plus B upon 1 minus AB. Similarly, if it is a negative sign, here it will be A minus B and here it will be positive sign. Next is sine inverse x plus cos inverse x. So adding them, it results into pi by 2. Same with tan inverse into cot x. If such a kind of function is there, the answer will be pi by 2 minus x. This you can use directly. So let us come to the differentiation of the composite function, and we solve the composite function differentiation with the help of chain rule. What is chain rule? You have to keep differentiating till you have differentiated the standard form. Till the standard form is reached, till that time you have to keep the differentiating the function. For example, if my function is y is equal to x square plus 1 the whole square. So this is not a standard form. Our standard form is variable raised to constant. Now this variable is not in a standard form. It is something x square plus 1. So this becomes my composite function. Composite function means inside a function there is another function. So if I write it properly, this is nothing but if you consider this as a separate function g of x, I can write it as derivative of f of g of x. Means inside the function f we have another function g of x. So to differentiate this, we make use of chain rule. Chain rule says that if it is derivative of f of g of x, first we have to take the derivative of f of g of x, that is f dash of g of x. Then we have to multiply it with the derivative of the function which is present inside it, that is g of x, then derivative of g of x. So in this case, we'll find the derivative of x square plus 1 the whole square into derivative of x square plus 1, which is the function inside this. So derivative of x square plus 1 the whole square will be, let us assume this as a variable and this is a constant, that is n into x raised to n minus 1. So 2 into x square plus 1 raised to 2 minus 1, that is 1, into derivative of x square plus 1. So if we separate this, derivative of x square is 2x plus derivative of constant is 0. So this will be 2x into 2 into x square plus 1. If you solve this, the answer comes out to be 4x into x plus 1. So this is how we solve the composite functions. Now let us come to trigo substitutions. So these four formulas or these four substitutions are very important. First is if you have under root of a square minus x square. So a is constant here and x is our variable. So in this case, we either substitute a sine theta or a cos theta. Second is if you have positive sign here, a square plus x square, we substitute a tan theta or a cot theta. Next is x square minus a square. Then we substitute sec theta or cosec theta. And if it is under root a plus x upon a minus x, we substitute cos 2 theta. These four substitutions are important. Other substitutions are based on the trigonometric formulas. Like if you have x function 1 minus 2x square, so you can here substitute x is equal to sine theta. So it will become 1 minus 2 sine square theta, which is nothing but formula of cos 2 theta. Similarly, here if you substitute cos theta, it is 2 cos square theta minus 1. Again, it is a formula of cos 2 theta. 2x upon 1 plus x square. If you substitute here tan theta, it will be 2 tan theta upon 1 plus tan square theta. It is nothing but formula for sine 2 theta. Similarly, 2 tan theta upon 1 minus tan square theta is tan 2 theta. Then 1 minus tan square theta, 1 plus tan square theta is cos 2 theta. Then we have formula for sine 3 theta, cos 3 theta, tan 3 theta. So in the place of this variable x, if we substitute these trigonometric terms, then we'll directly get the trigonometric formulas. Last one is 2x into under root 1 minus x squared. If you substitute sine theta, it will be 2 sine theta into 1 minus sine square theta is cos square theta and under root cos square theta is cos theta. So it will become 2 sine theta cos theta, which is nothing but sine 2 theta. So these substitutions you have to remember. Next is logarithmic substitution. So if the function is a combination of, so there are three things possible here. First, I have n number of functions, f of x into g of x upon h of x. This is also a function, this is also a function, this is also a function. Then I can have function as under root of f of x into g of x upon h of x. Or I can have the function in power, in under root, in denominator, in the multiplication like this. So these kind of problems are solved using logarithms. So for example, if you take y is equal to f of x raised to g of x. So this is function raised to function. So if you take log on both sides, this will become log y is equal to log of f of x raised to g of x. Now here we will apply the property of log. Log of a raised to b is nothing but b log a. Similarly, log of f of x raised to g of x will become g of x into log of f of x. So to solve this, such kind of functions, we make use of logarithmic substitutions and we apply the logarithmic properties. Next is implicit functions. So what are implicit functions? So these are the functions which includes n number of variables. So they include both dependent variable as well as independent variable. As you can see here, f of x comma y. So in this function, both variables x and y are included. So it is a combination of variables. So we can't separate here x and y. So how to solve these implicit functions? For example, my function is x square y plus x5 plus x is equal to 3 and we have to find dy by dx. So here you can see that we cannot separate x and y separately. We cannot make a separate equation of x and y here. They are combined together. And we have to find dy by dx. So in this case, we have to directly differentiate with respect to x. So if we differentiate this function with respect to x, so here we'll apply UV rule. First we'll keep y as it is and differentiate u, that is x square, it is 2xy plus, then we'll keep x square as it is and differentiate y with respect to x. Y is not constant, it is with respect to x, it is dy by dx plus xy. Here also we'll apply UV rule, so it will be 1 into y plus x into dy by dx plus derivative of x is 1, that is equal to 3. That is equal to 0, derivative of 3 is 0. So after differentiating with respect to x, now we have to find dy by dx. Now we'll solve this equation. We'll solve this equation and find the value of dy by dx. Now this is a long process. Now if it comes for the MCQ, you have a trick here to solve the problem by MCQ. Dy by dx is nothing but negative sign, negative of differentiating this function. For example, this function x square y plus x5 plus x is equal to 3. This is my function. First, you have to differentiate this function with respect to x, and here we have to keep y as constant. Means you are treating y as constant. Okay, divided by differentiating x comma y with respect to y. Now we will differentiate it with respect to y and keep x as constant. Okay, so this is a trick, and we will solve these sums afterwards. Next is parametric function. What is a parametric function? So here you can see y is also a function of t and x is also a function of t. Now this t is nothing but the parameter. So both this x and y is a function of t. These are known as parametric functions. To solve this parametric function, first we differentiate y with respect to t, then we differentiate x with respect to t, and then we divide dy by dt upon dx by dt. Let us see one example here. So we have two functions, x is equal to 4 plus t square and another one is 3t square plus 2t. And now we have to find dy by dx. Now here you can see x is a function of t as well as y is a function of t. So x is function of t, y is function of t. So first we'll find dy by dt, means we'll differentiate y with respect to t. So this will become 6t plus derivative of 2t is 2. And dx by dt will be derivative of 4 is 0 plus t square is 2t. So this becomes 2t. Now we have to find dy by dx, which is nothing but dy by dt upon dx by dt. So it will be equal to 6t plus 2 upon 2t. If you take 2 common here and solve, your final answer will be 3t plus 1 upon t. So this is how you deal with the parametric functions. The last part is higher order derivatives. Higher order derivative means now till now we have seen about the first order derivative dy by dx. This means first order derivative. If you again differentiate that dy by dx, it will be second order derivative. If you again differentiate it, it will be third order derivative like this. So second order derivative is denoted by d2y by dx square, or you can say y2 or y double dash. So these are all three notations for denoting two second order derivative. Now, as you can see here, dy by dx is equal to dy by dt upon dx by dt. If you have to find d2y by dx2, is it equal to d2y by dt square upon d2x by dt square? So it is not equal to this. This is only for first order derivative. In this case, it will change. I will deal with these problems in the next part of this chapter. So till now, we have revised the basic formulas of differentiation. Then what are the substitutions needed? Trigonometric substitution, inverse trigonometric formulas. Then we have discussed about a composite function, implicit function, parametric function, logarithmic differentiation, and higher order derivatives. In the next class, we will solve the PYQs of this chapter. Thank you.